Hi there. In this video I'm going to attempt to convert this EINHELL trimmer, grass trimmer, from this type of blade to wire. So let's see how that goes. For a sanity check, I bought a really cheap spool from Lidl. I think it was $1 a piece or something like that. And I will reuse the wire because this is not the final form. I just did a few minimal modifications. I'm going to attempt and undo this. Nope, I need to get back to you in a moment. Okay, and it's out. So what was initially here is this, with this thingy on top of it and this screw right here. Why I want to change that? This is quite hard and I need to cut the grass quite close to concrete. So this hits concrete, chips at the concrete, also damages itself, and also the motor itself started to wobble in here. I will also open it up in this video to make sure that this will be made a little bit tighter in here than it is at the moment, but that's not our main concern. I want to switch to wire because this is a little bit softer on the concrete itself and I can get closer without big risks. So what I did now, you can see I have all kinds of elastic washers used as spacers in here to center on this. Then I cut at the plastic and put a huge washer in here to hold it in place with a screw in there. It was, and I also needed two spacer washers underneath it to hold it in the correct height. But it was a sanity check. It basically worked. And yes, this is only the spool. This is not how it's supposed to work. I drilled my own holes in here. Normally they are not drilled. This is working in a completely different way and it's for a parkside trimmer, but I did a sanity check and I can reuse the wire in my new spool that I will be buying especially for this. The small problem is this has an M6 hole and most spools come with minimum M8, so it's not like I can put a screw in here and then continue on the other side of the screw with a different spool. I need to make some kind of adapter from this to the other spool, so that's gonna be quite interesting, but I think we'll figure out a way for this to work. So initially for me I want to try and make sure the motor stays in there a bit better, so I cleaned this area. I wasn't remembering how I can take this up and it seems I need to kind of push on it or something, or maybe lift it. Yeah, maybe lift it and then I can get it out of here. Don't remember exactly how. Yep, it's a simple clip in there. So now I have much better access and I can put this in some water to get rid of all of that if I open it up. And now I'm trying to look at in here and understand if this is part of the motor itself or it's just a screw in part on the motor, because that can change the way I will do this. If I look a little bit more, the engine is just screwed into this thing, the motor, not the engine, and it has an M6 shaft itself, so I might want to remove this and rethink the whole design. I cannot hold on to it enough. I'm thinking I might start opening it up. Anyway, I need to open it up, but I wasn't ready yet. Too late now. Let's do this. And this is what we have inside. So not sure how much I will be managing to keep this more in place. I think when it was new, probably it was already quite loose, But hey, I will be putting a bit of rubber in a few key areas, at least as a bit of damping. But yeah, not much more than I can do. But at least everything seems to still be fine and dandy in here. Decent size motor for what it needs to do. But I just need to undo this from that screw. From that shaft actually. Trying to undo the end. It's in this vise and I cut this slit right here so I can try to use a flathead to undo it. Not working. So either there's no thread in there and it's just pressed, or just more force is required. Maybe it's stuck, maybe they put something on it for it to not come loose. The more I think about it, the more I think it's actually pressed in here, because how would they hold the motor shaft in place to tighten this onto it? I didn't see anything at the end of it, nothing at the front of it, and this is not small enough to go through the hole, so it would be put in there before assembling the motor. So yep, I think it's actually pressed. Okay, change of strategies. I'm leaving this on and I will have somebody machine a screw for me, modify an M10 with 1.25 millimeter pitch. So that's I don't know, a more fine thread than the standard 1.5 millimeter M10, and it will make one of the ends into a standard M6. So it will go into this. So I'm just transforming a screw from any random store on a lathe, I don't know how that's pronounced, into a kind of adapter. And at any point in time I can just remove that screw and come back to the original disc with this sort of blade. So win-win in the end. I don't think this is worth getting out if the motor does not have a thread on its axle. To put everything back, make sure the wires go into that slot right there. Then this should come on top. Align it in here with the hole. Kind of hard to do this with one hand, but it is aligned. This went into position. Now we need to make sure we put this in its correct position. I have split some of this rubber hose. I think it's actually kind of silicone hose, to put it on this where the engine, the motor sits. Put just a tiny bit of glue so it will not start moving. Anyway, the engine will press it, the motor, and I will also put some of this somehow on this, and put a dab of glue on both screws so they don't come loose, and continue the assembly. I present you the current situation. Forgot to clean this, but whatever, I'm not doing it now anymore. It will be dirty in the first use anyway. The spring is back in place, so the longer part needs to be on the top side and next to this, because this is the shorter one, which is next to the red part. Put this in here, this, and now in theory, boop, close it back up and hope it all goes well. And we shouldn't have play in this by the old motor moving, because we started to wear through the plastic, as you can see here, because of all that movement. So in theory this silicone will provide a bit of cushioning. Okay, everything seems to be in place. We just need to tighten this back up with screws, and all should be good, I hope. No movement whatsoever anymore. And I didn't need to over tighten the screws. The silicone hose that I put allowed for this to tighten right back up in place. Zero issues. Perfect. Now let's put this back in here. And it locked. And now let's get this thingy back in its proper location. try to run it as little as possible with a blade that's worn down, because this creates an unbalanced. It's balanced when the blade is new. The more it wears down, the more it will pull on the shaft of the motor itself, and it will damage it in time, because those bearings are quite small. So yeah, but for me it will be way less vibrations, I think, at the moment. Of course I will put a new one of these, but we will continue the upgrade next for you. But for a while I need to use it like this. I cannot wait until I get that screw made. So a while later I actually bought one of those heads, big ones, with M10 fine thread and left hand, I think. It was too big for this, so I didn't even bother trying. Also the screws that I bought obviously were the standard type, to say like that, so the wrong thread direction, so it got just too complicated, and I realized the head was too big for this. It would just damage the little motor. So I went shopping, and my father actually found from a guy selling stuff to fix these sorts of things, small ones for electrical trimmers, and they have a 7mm hole, so we'll be passing about a 6mm screw through it, and probably just put some kind of spacer in there. And even this, it's much finer. I think it's 1.5, 1.6 or something like that. And as you can see, it's normal size for this size of machine, not the huge ones. So let's undo the screw and see how can we attach this in here. Open this up. This is what we have inside basically, so a thread and this, which I can refill at any point with this cutter wire. I wonder if we have the correct direction of rotation for this, because it does seem to give us a direction. So worst case, I need to open this up and reverse the wires if we have a wrong direction, because otherwise this might not work properly. Anyway, that's for later me to worry about. This doesn't have a pass-through hole, so I want to drill a 6mm hole, exactly the size of the screw that will be going into the end of this. Through here I will go, and then widen the center hole, not all of it, just a bit, so it aligns and mates with this outer side. I'm not sure how big that is. Hopefully I have enough material in here. This is should be quite strong, so PA6 glass fiber 30%. I think it's strong enough that I will not damage it, and it also has a lot of reinforcement in here, so should be good. Worst case, I need to buy a new one of these if something malfunctions, but I think I'm good, because only a tiny bit I will do that, just to align better on this and be more studying there. So let me measure the outside of this, but first drill the 6mm hole. Okay, some actually, no, probably most of you will disprove, but it is what it is. I needed to drill this hole deeper because the end of it wasn't perfect. It was made with this, and basically I was rotating this on it slowly by hand, otherwise it would just go in and dig out. So I drilled it deeper than the length of this, so obviously it would hit in here, these blades. And I kind of want them in there to throw away everything and not let them accumulate in here. So I'm not going to start removing them. Also, they give a bit more sturdiness to this whole plastic. So I'm using some washers as spacers. Yeah, stop booing me. I know it's not quite right, but whatever. So now this centers right here quite nicely. Probably it's not extremely well balanced, as you can see, still wobbling a bit, but when it will be tight, it should stay fairly well in place, because we do have somewhat of a flat surface in here, sitting on a somewhat of a flat surface in there. So we'll be seeing how well it works and if it does hold up or it disintegrates. But now in here we have this that fits over it, so I have about two chances. Either I use this, try to find a wider spring that can actually go over the whole thing in there, not only this little top, because this only goes above this little top, as you can see, not above the whole piece itself. But this might be tricky. Let me search and see what I have. Okay, so this is the only thing that I found. I needed to stretch a little bit to give it more force when it gets compressed to about the size of this one, because this is a bit tougher, actually much tougher. But now this one in theory has also a bit more force when I try to compress it beyond a certain size. And I hope that I didn't stretch it for nothing. No, I didn't. It actually fits and sits in position, which is perfect. So in here it kind of stays there in the middle more or less, and it actually centers in here better. So hopefully it's good enough to not have issues. This is kind of concave, so it does center the spring a bit by itself, which I think is enough. Hopefully we'll see if I need some other centering in there, although it's kind of in the middle, so even if it's off center a little bit, I don't think it's enough to create too much vibration. But yeah, I'm guessing, I'm trying, I'm whatever. So hopefully this also fits over, yep, this, because this one obviously didn't. And kind of this is the screw that I was hoping to use, 6mm one. If it wants to go down there, hopefully, it's too long, I need to cut it probably. And then if it crushes that, then we might have a bit of a problem, but we'll see. Cut the screw, hopefully not too much, but we'll see. And to also have something that kind of engages with the sides in this, oh, wrong side. As you can see, I dremeled with this sort of Dremel some dimples, and I will be using hot glue on this and inside of this, lots of it. And I'm not using it for its gluing properties. It will be there just to provide some mechanical interference. And basically having these dimples, it means it cannot slip on these, because the material from the dimples itself doesn't really have anywhere else to go if it tries to rotate. Yes, it will maybe have just a tiny bit of give, but I don't care. Some vibration absorption is okay in this situation, but the most of the rotational force will be transmitted just by clamping this with the screw. That is just an addition, and also it will help hold it in place while I tighten the screw, because otherwise you have nowhere and no way of holding this in place while tightening, because this shaft can rotate in there while you try to tighten the screw. I could open all of this up and use that slit that I made in the other end of the shaft to hold it in place, but I will try first like this and see how it goes. Just another thought, I know I could have dremeled from the start just for this and this side directly in this. Not sure how centered it could have been, maybe it was a better idea to do like that, but it's a bit late now, isn't it? Okay, a bit of carnage in here. I decided to remove completely all of those walls that were basically a grass guard, so it doesn't come into the motor. We have a different design here. Yeah, I know maybe it would have been better if they could stay in place, but no. I wanted this to go as far down as possible, because I want to not put too much stress on the bearings of this motor and wear it out too quickly. This is much taller than the original thingy. You can clearly see that, I hope. And this is not even its final form, because we are adding stuff to it a bit. At least the button will be taller. So at the end of the day, I wanted to go as low as possible. Those were removed. File down this so we have a flat surface. Again, this was removed, and now we are much closer, and this should be way better. It's there. And I think I'm also going to remove this guard. I never used it. It just makes things harder to clean, and it gives the possibility for it to somehow slip and reach into this thing and wreak havoc. I don't know how to pronounce that. To remove it, you simply pull it to the max, and then you can spread it apart and spread the other one apart at the same time, and then just pull it even further. Just an update, I put a battery in and checked. This is spinning counterclockwise. Exactly what we need. But maybe even if it spun the other way around, maybe I didn't need to open it, because I think it's all about the direction this thing is threaded in. So maybe I could have just changed that and be done with it, but no, it's exactly the correct rotation, so perfect. Okay, I made this screw only 15 millimeters long. The thread of it is 15 millimeters. In this particular situation, that's about it. We still have some thread lock in there, although I don't think we will benefit from it. So I'm using this spring washer, or whatever it's called in English, so it will keep even pressure. Now in theory, just get this out, put some of the hot glue in here and obviously in there, put everything together, tighten the screw. Actually no, wait for the hot glue to dry up, and only then dry up, I don't know, become solid again, and only then tighten the screw, because I need it to hold on to this while I'm tightening. Wait a second, if I remove this, now I actually do have some room in here, so I could either try to use this, but it's not quite narrow enough. I have one a bit narrower, still not enough, so I can actually file down and make two facets on that metal right in the middle, and I can use a spanner, wrench, spanner, whatever. With this, a lot of care, and by holding this little guy with the 8mm socket like this unmoved, I managed to make one facet here, one facet here for this 13mm socket. So now I can tighten whatever I want without issues, and untighten in the future without issues. That's perfect. Keeping this screw in here so I can apply hot glue on the sides. It's not going to be easy at all, but I am going to do my best to do it. And when I pull this out, the hole in the middle should be more or less okay and in place, although I should be using a stick without yes, without threads no good for what I'm doing here. Let me search for something else. You know what, I'm going to attempt to apply it by holding this and letting the hot glue just flow in there and not occupy the hole. Then the same, I will put the hot glue from here and make sure it doesn't occupy the hole, and then move quickly and hope for the best. Probably it won't work, but I can always start again. Hole is more or less free, so now let's put this and hope for the best. Fully tightened, and I'm not sure if I can show you, but also really well centered. So everything is in place. You can see some hot glue in there. I was able to tighten this really well, so it will either work perfectly or fail perfectly. There is no in between, in my opinion, at this point. Let's I don't know, put this on, for example. I think it's on, and put our spring in here, which is also great, and the little cover on it. I hope it's the correct position? I think it is. And these things I can buy quite cheap, so even if I break one of these heads, I know what modifications I need to do to it to work in here, and they are minimum. So that's great. And now, although this is the spinning direction, and the cutting level, I think it's right at the level of this, or just barely above it. So maybe it will throw some stuff. I can extend this if I ever feel like it and I need to, but probably not. Okay, I will give it 2 or 3 more minutes and go play with it. Just an idea, some sizes for this head. Well, it's about, how much? 7.5 centimeters in diameter. Total height of it, starting from here, it's about 5.5, something like that, more or less. And let me measure this thickness. Let's see what we can do with one single hand. It's about 1.5 millimeters. Initial test will be done with this 2.5 amp hour battery. I don't want to give this too much oomph at the start. I don't think it will exceed 10,000 RPM. These things mostly are rated at 10,000 RPM, but I don't think this can do more than that. Does it have 8,500 RPM? So yeah, that's a-okay. Let's get to it. And it seems that its cutting radius was 24 centimeters. As for the length of the wire, I'm not sure if I will add something on this to cut it automatically, or I will just cut it right about here, about 1 centimeter smaller than this. And it's working. So that's great. Nothing moving, nothing wobbling, but yeah, it was just a quick test. I'm not planning on hitting it on the ground to release this. I'm planning on putting it like this, pressing it and pulling on the strings, and they will release whatever much I need. But it might really benefit from a cutter for these wires in there, so I might be adding one. I need to take a bit of a look online to see what's their shape and how they are made, but I think I am going to add a cutter there. That would just make things way less complicated, and I wouldn't need to carry this with me to trim it myself every single time I extend it. But overall, it's just a little bit weaker in cutting power. Maybe this is also quite thin. I think the one from Lidl that I bought might be a bit thicker than this. But anyway, a little bit lacking in cutting power compared to the blade. But then again, this does not force the motor as much as the blade does, doesn't give it near big enough shocks compared to that. So yes, overall I see this as a win-win for what I need. Also, this will not damage the edges of the concrete where I need to trim the grass and weeds. The other one would damage it if I wasn't really careful. So for the moment it's perfect, exactly what I need. But we'll see how it behaves over time, because only time will tell what happens. Trying to even bring some improvements. This is just a piece of metal from an old printer that I turned down. Seems to be quite a strong steel. Drilled some holes in it. I will sharpen just this end of it and attach it in here with something like this, and hope it works well and cuts. We'll see. Well, this is what I did. Put a washer in here, but it was too big, so this went right through it, but it stays enough in the plastic for that particular position, the last one. Found other washers for these two. Hopefully this actually cuts and doesn't bend. I have no clue. It's quite a strong material, but it's not spring material, so could work, could also not work. Let's put this on and see what happens, basically. it actually works. Look at this. It cut both of them. Okay, so for the moment this is a fully working device. For how long? It remains to be seen, but you'll get updated next. I've also seen that this basically damages its own wire right at the point of exit. So I'm not sure if this is a bug or a feature, but I'm going to file down that edge that you can see right there. I don't think it's a feature. It's too random to be a feature. It's just China quality. Much better. So at this point I will start using it and hope it lasts a long time, because overall it seems to be good, but only time can tell. A bit later upgraded this assembly a little bit, put here a washer where before it failed. Now that is a bit stronger, obviously a new pop rivet. Also removed this old pop rivet and put a new one in all of this shit right here that you can see, and these two metals are held together with another pop rivet. There's a washer for this one again to strengthen it. So now our cutting blade, which is this one, cannot bend from the tip because this metal does not allow it. This is softer metal that I could bend to my will. This is again tempered metal. So that one hardened, actually. I don't think tempered is the correct word for it. Hardened. So this one will keep its sharpness longer. Also made this one a bit sharp, but this is soft still, so in time this will round itself again. But this blade will remain sharp, and yeah, it cannot bend anymore. So in theory, all of this assembly now, it's, you can see I cannot bend it with my fingers. Whatever I press on it doesn't matter. It's fully closed in here and it will not bend. So now let's play with this and see how well it cuts these things, and if it cuts them, it's done. We are done. Extended this, so it should require cutting. We'll see how it behaves. Yes, it could hit the plastic first, but it will still hit then the metal. So it will be cut no matter what it tries to do. And to extend them again, I pull on both of them at the same time and push on this. I don't hit the ground how this is actually supposed to work, because this is not sturdy enough in my opinion to be doing that. So let's try and cut some grass. As you can see, it's cut exactly where it should be cut. So this thing is working perfectly and it's sturdy now. And it's cutting perfectly, exactly as it was doing before. So our modification worked. And that's about it for this video. It's finally working as intended. It's able to cut its own wire to length, so I don't need to bring scissors with me and cut it myself. Yeah, not chipping the edges of that concrete slab like the blades were doing before. This I can buy much cheaper. Yeah, for me this is what I wanted and what I needed, because I need to trim the grass a lot next to concrete. If you don't have that situation, maybe something like this for you doesn't make sense. But for me, it actually did, because I couldn't really use this tool as it was before. So yeah, that's about it for this video. Hope it helps you, and I literally think EINHELL could sell some upgrade kits for these things. New one of these with a proper cutter in place, something like this that directly bolts onto the factory unit, and yeah, cut away. So yeah, hope this video helps you again. If you have any questions how this works over the years, ask in the comments, and as always, see you in the next one. Bye.